So in this video I want to show you how to analyze the strain life fatigue properties for a particular material. So in our project materials, I guess let's review the project steps here. We did the first part of this using Massing's hypothesis. Determine the strain life fatigue constants for MS6000 sheet steel using the data supplied. Turn in a report including plots to show how well your 1070 properties fit to the experimental data and Massing's hypothesis. Include a plot for the MS6000 sheet steel to show how well your constants fit to the experimental data. So if we go into fatigue properties, you'll see this README file. And it says the file in this directory contains fatigue life results for strain control set of fatigue tests on a sheet steel, strain, stress, number of cycles to failure, and plastic strain. The modulus of elasticity for this is 29,500 KSI. Alright, the stress amplitudes are in KSI and the strains are in inches per inch. And the data is in this form right here. Again, these are the number of cycles to failure. Here we have the various properties. And here we have the data here. Now I'm going to bring up my Excel file, which is here. And based on the elastic strain amplitude, we can go back and calculate the plastic strain amplitude as well from the total strain amplitude. This being the number of cycles to failure and this being the number of reversals to failure. So what we can do is we can make a plot with a trend line for the plastic and then the elastic data. I know this is kind of hard to see. Maybe I can zoom in on this a little bit. Excel likes to whine about some of these plots. But here you see this is a log-log plot, number of reversals to failure here. And these have been fit to this data. And you can see there's a little bit of things going on with the data. Now I added, I clicked on the line, I added a trend line, and I added an equation. Let's see if I can do that. So the equation that I fit was a power law equation that would plot as a straight line on log-log coordinates. And then I displayed the equation and the r squared on the plot. So this fits the data pretty well. The r squared is equal to about 1. I mean, I think you can probably expand this out to more digits. But this value gives the epsilon f prime, and this is the c, and this is related to the sigma f prime and the b. Now remember, the coefficients are, if we were to take and extrapolate this value out, this is where the value should hit out here somewhere. And the 4.46 is the red one that goes out here, and the 0.034 is the blue line. The elastic equation should come out here somewhere. Okay, so I let Excel do the work. Now, in order to get the sigma f prime, I took my modulus of elasticity and multiplied it by the 0.0034 whatever. I only have 2 significant digits here. Obviously, if you carry out more, then you can get more. But what I want you to make sure that you do is that you see and you check how well this data does against, this fit does against the actual final data. And the final data is in terms of the total fatigue life and the total strains. So this would be the log of the number of reversals to failure, and this is the log of the strain amplitude. This black line is the strain life, a curve that goes from 4 cycles, I guess, out to 2 million or whatever this number is over here. This is the actual data that was collected. Of course, this decomposition assumes that we have the right modulus of elasticity and so forth. But here you see the triangles, and some of these fit better than others. Okay, looks like this one doesn't quite follow on the curve. There could be reasons for that experimentally. But for the most part, from here to here, the data and the trend line does very well. Now, anything beyond, what, 8,000 reversals is an extrapolation. So use this data out in this region with caution. Okay, will it fit this line or not? Well, we could do a few more tests maybe, but like I said, it's very hard to do fatigue tests at very low cycle strain amplitudes that lead to very low cycles of stress or to failure. Reversals or cycles, so forth. Okay, so please do take a look at this data and analyze it yourself. Don't just use my coefficients, but take the coefficients that you come up with and plot them in. And I want you to show me that you have done this comparison between what the fit is and what the actual test data looks like. With that, then you can wrap this second step up for your project and turn in your report.